Today we are on lesson 7.5 and we're talking all about using tree diagrams to calculate probability. So our goal is to be able to simply do that. Use our tree diagrams if we have fractions there and go through and try to determine the probability of a certain outcome. Looking on page 260, which I have here, we are supposed to complete the tree diagram for each maze. So if I zoom in, you can see that in our first example, number 1, we have a maze over here, and then we're going to be filling in our tree diagram here that correlates with that. So write a fraction next to each branch to show the probability of selecting that branch. Then calculate the probability of reaching each endpoint, which our endpoints are down here, and also these would be our endpoints. Record your answers in the blank spaces beneath the endpoints. What is the probability of entering room A and the probability of entering room B? We can't really determine that yet because we need to do our tree diagram first. So I'm going to try to zoom in as much as I can where you can see both things, and I can still kind of write a little bit neatly for you. Let's go ahead and start. So as we're entering, they have our first path here marked as 1/4 probability. Now that helps me fill up my other ones because I can see there are 3 more, altogether 4. So these first ones are all going to be a probability of 1/4. If someone blindfolded me, spun me around, and made me face that direction, randomly chose, I'd have 1/4 probability of entering each of those 4 hallways, we'll call them. Then I'm going to change my pen color. Now if I'm at one of these 4 points, I have new probabilities. I have 2 ways I could go there, 2 ways here, here, and here. So each of those, I'm going to make a little star. If I'm at this point, I have 1/2 probability of going through each of those hallways. Again, on the next one, 1/2. Because there are 2 pathways, equally likely to choose one or the other. So all of these would be 1/2 probability that I would be going into one of those pathways. Now we get down to the bottom, and we're not going to worry about room A or room B yet, but we have to determine what our final probability is to go through each of those different places. So here, for example, what I'm going to do to find my probability is multiply my branches of my tree diagram that got me there. So I'm going to use my highlighter. If I follow this exact pathway to get down there, that would be 1/4 times 1/2, which would get me 1/8 probability. If I switch back to my highlighter, let's say I take this first path again, but now I branch off here. Same thing, 1/4 times 1/2 gives me 1/8. And you guys can probably see the pattern for this tree diagram, that all of these would be 1/8 because they took very similar paths and split off the same equal amount. Now we can think about answering this problem up here. What is the probability of entering room A? Well, it's not just 1/8 because I have to look here, and to enter room A, I could take this path, this path, this path, this one, or this one. That's 5 different entrance points. So I need to add those up now. So my 5 different entrance points would be these 1, 2, 3, 4, 5. So adding 1/8 5 times, or 5 times 1/8, I would have the probability, 5/8 probability of entering room A. We'll figure it out the same way with room B. With room B, I can look at my final entrance points. I have 1, 2, 3 of them, so I need to add up 1/8 plus 1/8 plus 1/8, which gets me 3/8. Now because those are our only 2 outcomes, these 2 should add up to a total of 1, and 5/8 plus 3/8 does equal 1, so we did that correctly. We are also going to look at the second problem on this page because this one is a little bit different. Again, we need to figure out the probability of entering room A or room B, but as we fill out our tree diagram, we'll have a couple different things to look at. So again, my first path, I could take this way or this way, highlighting on my tree diagram, same thing, and that means I have an equally likely chance of going through one of 2 which means out of those two, this would be 1/2, and this would be 1/2. Now moving forward, this room has this pathway has 3 branches. This one only has 2. So our fractions over here, if I have 3, would be 1/3, because I have 3 different possible paths I could take. And over here, I only have 2, so my fraction will be 1/2. This is a difference in this tree diagram from our first one, because now we don't have the same type of path here. Okay, looking down further, now we need to figure out our final probability. So to get there again, I'll use my highlighter. Let's say that I took this first path, and I just kept going straight, and I got here. Following that same path here, that would be 1/2 times 1/3. So my probability would be 1/6 of entering at that point. Now, let's just hop over. We're going to look at a totally different one. Let's say I took the other way and went completely straight the other way. Now, looking at that here, I would have 1/2 times 1/2. Very different, and that would give me 1/4 probability of entering that path. So when we follow these paths, we need to be very careful that we're following that exact path using those exact fractions. 1/2 times 1/3, 1/2 times 1/3. So both of those will also be 1/6. And then looking over here, 1/2 times 1/2, I'm going to get another 1/4 probability. Now, to figure this out, what is the probability of entering room A? So let's take a look at room A here. I have 2 entrance points, and looking very carefully, that would be this probability and this probability, 1/6 and 1/4. Now remember, we added these together. Now we have 2 different denominators, so to do that, I'm going to go 1/6 plus 1/4. I need to find a common denominator. I'm going to use a small one of 12. You could go up to 24, it doesn't matter. But if I use 12, then I should have 6 times 2 would be 12, 1 times 2 would be 2, 4 times 3 would be 12, so I need to do 1 times 3, which gives me 5/12 probability of entering room A. Room B, same thing, those are all of my leftovers, so I'll use stars. Now I have 2/6 plus 1/4, 2/6 plus 1/4, so same thing. And we'll find our common denominator of 12, which would give me 4/12 plus 3/12, with a final answer with a probability for room B of 7/12. So this one was a little more complicated, but same idea. Your assignment today, we already completed Math Journal page 260. If for some reason you did not, you need to complete that on your own. You also have Math Journal pages 261 and 262 to complete. For IXL today, this is some review. You've been doing this for a while. II1, II2, forgot my comma, II3, making predictions, and I'm going to add a challenge in here today, II5, because it's giving you compound events where you have a couple events happening and you're trying to find the number of outcomes, which is kind of similar to what we're doing with our tree diagram today.